Hey, my name is Gleb Alexandrov. Welcome to the first tutorial from that part of the course where we're gonna be focusing on different techniques of creating Photoscan 3D environment assets like this roadblock. And actually we're gonna start off by recreating this precise roadblock. First, we'll pre-process the raw photos captured on an average mobile phone in Darktable, a freely available software for developing the raw photos. Then we'll align the photos and reconstruct the mesh in full detail in Reality Capture. After that, we'll clean it up by removing the redundant areas and filling in the gaps. Then we'll use the Blender's sculpting capabilities to further tweak the mesh. We will simplify the mesh for baking textures, then unwrap and reproject textures in Reality Capture. To make it a really versatile 360 degrees complete asset, we'll inpaint the missing textures by utilizing projection and clone stamping in Blender. Finally, as a bonus to this video, we'll learn how to use the AI-based upscaling to resize the albedo texture. It'll be a totally magical part. I recommend you don't skip it. And hopefully after watching this tutorial, you'll be able to get something like that. Feel free to download the sources to be able to follow along and buckle up. Before we begin though, a quick disclaimer. The source photos for this tutorial were captured on a mobile phone in RAW format. No expensive DSLRs were involved. Our workflow of creating Photoscan 3D assets starts in Darktable. It's the free and open source software for processing raw photos. And let me start off right away by dragging and dropping the raw files into the user interface like this. As a plan B, if it doesn't import, use Add to Library button. Hit plus, then navigate to the folder with the source photos and proceed from there. If for some reason you don't see the left panel with import, you can hit this little triangle to expand it, because it's collapsible. The left panel also has the Image Information tab, which is pretty useful. You can check the model of the camera used. In our case, it was a pre-average mobile camera, and other parameters like resolution and so on and so forth. The same goes for the right panel. If you don't see it, click on the triangle to expand. We will need a history stack panel from there, and also obviously the export panel to export the processed sources once we're done with it. Alright, to start the development process, you can either double-click on the image or enter the darkroom mode from there. In the darkroom, we develop our digital negative into something that can be exported out. First, let's click on this icon and select the scene referred defaults. We can also click on the little cog icon over there to enter the settings, head over to the processing menu, and apply the scene referred defaults. And while we are on this page, I would also recommend to head over to the storage menu and untick the write sidecar file for each image checkbox. Otherwise, Darktable will keep populating the XMP files, which I don't like. Now I'm making sure that pretty much all modules are disabled. Let's try to keep it minimal. The filmic RGB and other aesthetically driven adjustments should be probably turned off as well. I'm gonna quickly visit this menu again and enable all modules, just for a second, to see if the base curve is turned off. If you don't have the scene referred default in Darktable, you will probably have to deal with the base curve. The base curve is like the S-shaped contrast curve automatically applied to the source raw photos. Without such a curve, it looks visually washed out, but that's exactly what we need. We need to keep everything linearized, so the base curve should be turned off. Let me re-enable the scene referred tabs and start the actual adjustment process. First, I'm going to visit the white balance tab and adjust the temperature. To not completely eyeball it, I'm going to click on the eyedropper icon, and then I will try to define the patch of the image that I think should be the neutral gray. It's pretty hard to nail without the gray card reference present in this scene, or the color checker, for example. But if you didn't have one, just try to find a patch that is close to the neutral gray. I think that should be close enough. It's a good indication that the white balance is set correctly if everything starts to look a little bit yellowish. It means that the influence of the blue sky goes away, and that could look unnatural indeed. On the other hand, we are preparing the albedo texture, not the final image. Alright, the second thing after adjusting the white balance is to adjust the exposure. Of course, the raw files only have as much fidelity as they have. The exposure should be probably adjusted on set, but we can try to adjust it within a certain range in post as well. Just like with the white balance, it would be very handy indeed if we had the gray card reference present in the scene. The 18% gray card combined with the eyedropper could give us some reference point to measure. But anyway, let's not get too serious about it and just try to eyeball it. Oftentimes it's worth making it a little bit brighter than you think it should be. After all, it's supposed to be the albedo texture, and the values that you see on display will get linearized for rendering. To sort of help remove the lighting information from the source images, I will turn on the tone equalizer. I will tone down the upper bands, and hopefully it by itself will help to equalize the lit and shaded areas. Alternatively, you can use the mouse wheel while hovering over the certain portions of the image to adjust that band. While this is not an alternative for a proper delighting, that's a good starting point, and in some cases it could suffice for the final delighting. Like in this case, I think. Aside from that, I would adjust the sharpness levels. First, we disabled everything, now let's bring back the sharpen module. I will zoom in to see the effects a little bit clearer, and the only thing I'll touch is adjusting the amount. I will set it to 2. I'll suspect that the video compression will eat that stuff up, but to reiterate, the sharpen was set to 2, and it's good. Now going back over to Light Table where we have all our source photos, and in the history stack, I will press Selective Copy, and I will make sure that the white balance is also selected. I'm pressing OK. Then it's a matter of expanding the selection to all the sources by either pressing Ctrl A or holding Shift and clicking on the first and last image, and then Selective Paste. And OK. It looks to me like the development settings have been propagated to all 44 images, and now we just have to export it. The usual stuff. First we need to define the output folder. I created a subfolder within the source files to not accidentally forget where I put it. And what's for the settings? It's a good practice to stay away from JPEGs usually and use uncompressed formats like TIFF. 8-bit would be enough. For the 8-bit sources, sRGB can be the image profile. Then we can either export it in full resolution and then use something like XNView for batch resizing the images, or we can trim the resolution from the set size field, like 2K pixels wide, and finally happily export it out. The next stop after processing the photos is photogrammetry in reality capture, or the process of reconstructing the mesh out of these photos. In the top of the user interface, I will switch to 1+1 layout, and then we need to add the inputs. Once again, I will resort to drag and dropping into this tab. Still 44 images, meaning that we haven't lost anything in the process. You can check the resolution of the selected inputs, 2K pixels wide, like it should. It will also affect the price among other things. And now just hit the start button to create a virtual reality. Actually, no. It's never a good idea to do it like this. What we should do instead is tackle the workflow steps one by one, starting with aligning the images, then calculating the model, so on and so forth. So down into the settings of the alignment tab, let's check the image downscale factor. I think it is important to point out how the image downscale factor works in reality capture, because it can definitely be slightly non-intuitive. Basically, it's a multiple by which the application reduces the size of an image before feature detection. For example, if you input 3 in there, you tell RC to downscale the source images by the factor of 3. And if you input 1 in there, it's basically no downscale at all. I think the value of 2 is a nice starting point. So let's go with 2. And in the advanced settings, pretty much everything at their default values except the pre-selector features, which I cranked up a little bit. By default, Reality Capture keeps this value pretty modest. I don't remember exactly what it is, but in my tests, cranking it up to something like 40 or 50,000 resulted in more reliable camera matching. Okay, let's hit Align Images. It should be a quick process, considering that the initial resolution was pretty low. Luckily, all 44 cameras have been matched. You can see the point cloud, which is the sparse point cloud. Within the Tools menu, we have the Reconstruction region, which can be cleared, and the ground plane that can be adjusted. After clicking the ground plane icon, you will see the gizmo, and by using this gizmo, you can orient the model in space. It's usually better to do it from the orthographic projections, like the top one. And while it's not strictly necessary, it usually makes the life a little bit easier on processing the mesh later on. Aligning it from the left perspective and then from the front view. It's not clear whether the ground is a little bit tilted or the object itself. Okay, now back into the perspective view. Looks to me like it's oriented very nicely, and now we can set the reconstruction region. It can be shrunk down and tailored to the object by adjusting the handles, and it tells Reality Capture to process the mesh only within the confinement of this bounding box. Obviously, it helps to save up the computer resources, especially if the sparse point cloud extends far beyond that bounding box. The next logical step after obtaining the sparse point cloud is to turn it into the dense point cloud and to mesh it. These two operations are joined in Reality Capture. So let's head over to the Mesh Model Settings, Image Depth Map Calculations, and within the Normal Model tab, let's check the image downscale. As depth maps and mesh calculation is the most resource-intensive step in the whole photogrammetry pipeline, you should be careful with the image downscale. 1, meaning the original resolution, is not usually the best option right out of the box, but I know what I'm doing, and we have resized the source photos anyway, remember? So I went with the image downscale of 1, meaning the original resolution. And voila, after some 10 minutes of processing, which is blazing fast compared to many other software, Reality Capture really shines in that department. We got a pretty high quality mesh with 4.6 million triangles. I will call it high poly because naming is really important. I will keep reminding ourselves about the importance of naming throughout the course. Okay, so right after meshing, we can proceed with colorizing the asset. I'm checking that the texturing and coloring resize is set to 1 in the colorize settings and pressing the big bad button. Unlike texturing, colorizing uses vertex colors. It neither generates an UV map or texture, it just assigns the colors to the individual vertices of the model. And if the density of the vertices is enough, I think 5 million triangles is close to being enough in that sense, the final result looks just like a texture. Not having the UV map and the texture can be an advantage if you have to sculpt the model, or if you don't want to spend time generating textures, and in some cases texturing the really high poly model is practically impossible anyway. Alright, so here we got a nice high poly base mesh with the colors assigned to vertices. After that, to make the model actually usable, it usually has to be trimmed or cleaned up in some way. Even before taking this model to Blender for the mesh doctor work, it's possible to do some cleanup in Reality Capture. For example, with the help of the lasso selection tool and the filter command. First of all, I will clear the reconstruction region because it messes with the selection. And then I will isolate the part of the model that isn't the road block. You need a pretty steady hand in order to do that. With Control, you can add to the selection, and with Shift, subtract from it. So it's helpful to do it in a few steps without trying to nail everything at once, in other words. So I'm proceeding slowly and carefully with selection. Once again, with holding the Control key, you can add to it. And by holding Shift, remove the parts of the selection. If you feel more comfortable with doing it in Blender with the help of the Boolean tools or just good old selection in edit mode, go for it. In my opinion, the RC selection is slightly faster for the time being, especially when the mesh is spectacularly high polygonal, which is not the case here. Once the selection is finalized, I'm pressing the Filter Selection button within the Tools menu. That will delete the selected polygons, basically, and it will create a duplicate of the model with these areas cleaned up as well. Let's call it high poly underscore trimmed or something like that. So this will be our high poly model that we will be working on in Blender. So I'm gonna hit Export. We need to find the FBX format. Create a separate folder for the high poly model and just dump it into there after licensing the inputs, because the pay per input license means that we need to pay for the inputs first. As far as I remember, for this particular model it was something like $0.25, so pretty affordable indeed. But anyway, that's something to keep in mind, that Reality Capture is still a paid application. Okay, so the model should be exported now. Let's pick it up in Blender. The high poly mesh is still nowhere as clean as we would like it to be, so let's pick it up in Blender and keep rolling. As we have used the FBX format for exporting it out from RC, we should use it for importing it back into Blender. So navigate to the folder where we have put it and import that FBX. If the file is pretty heavy, it could take some time to import it. But here we go. Even though the quality of the final photo scan is far away from being perfect, I'm still very surprised at what Reality Capture was able to squeeze out of the source footage taken on mobile. There are a few places like these handles that I would like to see replaced, or reworked rather. And obviously this gap at the bottom needs to be closed if we decide to close the gaps. So let's get started. Within the viewport settings, the statistics enables the preview of how many faces and triangles and vertices and all that stuff our model has. So it's around 4 million polygons, still pretty manageable, although it starts to be slow in Blender. And as you remember, we have generated the vertex colors, so it can be previewed from the viewport options menu. That being said, we probably won't need that preview, but it's useful to have anyway. What can we do to close the hole? The most straightforward option would be to go into the edit mode, manually select the boundary loop or the edge of the hole, and just fill it with the faces. Let's give it a try. First I will press A to select all the vertices, then search for select boundary loop, and hopefully that will outline the edge of the gap very nicely, like this. What we can do next is go Face, Fill, or press Alt F. And that will try to fill it in with the faces like this, which doesn't look well, but after some tweaking, I think we will make it work. For now, it's just a rough, how should I put it, filler. To make it work, let's go down into the Sculpt mode. Sculpting is a remedy for many things related to photo scanning. Its huge advantage compared to stretching vertices in the edit mode is that it's fast. And on top of that, it has such a nice feature, dynamic topology, meaning that we can work with a pretty horrible soup of polygons, and dynamic topology will invent the new configuration of polygons on the fly. So right away, I'm gonna turn on the dynamic topology checkbox. It will warn us that the vertex colors will not be preserved. I'm fine with that, you'll see in a moment why. But actually, you know what, let's go back into the object mode and duplicate this road block just in case we do something awful with it, right? Shift D to duplicate, M to move to the new collection, I will call it Sculpt, and the original object should be put into its own collection called High Poly, and then I will move the stuff around in the outliner like this, and untick the High Poly collection. So we're left only with the Sculpt one. Now we're good to go into the Sculpt mode once more, and start fixing the bottom surface. I'm using mouse wheel to scroll the top panel until I see the dynamic topology checkbox. Let's turn it on. T to open the left tool shelf and expand it like this to see the names of the tools. I'm gonna choose the clay strips brush. The strength can be set to a really low number though, because I just want to recalculate the problematic topology there. What dynamic topology does is generates the wireframe on the fly, and the detail size can be tweaked in its settings. And what I'm doing now basically is I'm recalculating the problematic topology. When the mesh is pretty dense, it can become slightly less responsive than we would like it to be. But here it's pretty manageable at 5 million polygons, approximately. It was 4 or something like that. So I'm quickly brushing over the razor-sharp thin polygons created by the fill operation, massaging it very carefully. And when it's done, the dynamic topology can be turned off temporarily, especially if it got sluggish. And we can proceed with using any brushes we like, for example the scrape brush. It will help to reduce the pillow effect caused by the clay strips brush and to create some chiseled edges as well. I'm not gonna pay much attention to the bottom surface of the mesh though, because I just want to close the gap and then slap some texture on top of it, just so we have something to work with. I won't try to hammer it into looking the same as the rest of the model detail-wise. It just needs to be good enough to serve as a filler. So that's it for sculpting the base for now. Let's jump back into the object mode. There are things in life that can't be fixed by sculpting, like these metal rings, so I'm gonna replace them. Shift A, go Mesh, add a circle. I will keep it relatively low poly, so in the circle settings I'm adjusting the vertices to be 18. Then tab to enter the edit mode, 7 on the numpad to switch to the top orthographic view, delete the half of the vertices, select these two, E for extrusion, and it's extruded out like this. This is gonna be the carcass on which the flesh will grow. I played Death Trash a little bit too much, as you can see. It's a wonderful game, by the way, try it. So in the modifiers, search for the skin modifier. It will precisely make this thing fleshy. Smooth shading should be turned on. Then how to adjust the thickness? First, let's enable the X-ray mode in the viewport settings, then select the vertices and press Ctrl A to adjust the thickness of the skin effect. It's a pretty obscure shortcut, Ctrl A, but anyway, now we have to nudge this metal ring into place. R to rotate, G to move. So I roughly place it where the original one was, supposedly. It can be hard to tell, but it's not super important, we can nail it approximately. And when the left side of the roadblock is done, we can start working on the right one. So Shift D to duplicate it, R to rotate. There are cases when in the mesh doctoring process you realize that everything should be reconstructed from scratch. There is nothing strange in it, it's totally possible when dealing with photoscan meshes. Okay, I'm putting these circles within the sculpt collection and disabling the visibility of these circles temporarily because I'll be working on the base mesh now. Look, we recreated the metal rings, but we still have to remove them from the high poly mesh, right? So back into the sculpt mode, choose the clay strips brush. Now we need to remove these parts somehow. It's easier to do it with the dynamic topology turned on, I think. So let's navigate to the top menu, check the DIN topo, and then brush these rings out of existence with a higher strength like this. You can hold Shift to enable the smoothing effect. And right now DIN topo is set to relative detail, so if you are farther away from the model, the generated polygons will be bigger, so it can be used to our advantage. I don't care much about the details for now, just removing these parts. Now let's work on the top one. The process is the same. Shift to smooth it out, Ctrl to subtract, or to push the polygons inwards. As usual, I'm trying to follow the shape dictated by the reference model. Now moving onto the right side of the mesh and trying to dissolve the protruding parts there. It is almost satisfying to see these rings melting away under our brush strokes with the help of dynamic topology. It is such a useful workflow that we can remove geometry like that on the fly without caring too much about the wireframe and stuff like that. Thanks goodness we have such thing as dynamic topology implemented in Blender. And thanks Blender devs, as usual. And now back into the object mode again. I think it's time to re-enable the visibility of the circles. And I think we pretty much finalized the look of the high poly model. There's just a few minor things left, and we can proceed to creating the low poly alteration. Essentially, all that we do right now will result in two things, the high poly and the low poly mesh. Hopefully, if we did a good job with tweaking these meshes, there will be no gaps in both of them and no artifacts. So in order to start creating the low poly model, I will duplicate all that we have and move it to its own collection. But before we start working on the low poly one, I remembered that we still need to do one more thing, which is pretty minor and insignificant, but anyway. These metal details in the high poly version can be slightly smoother and high definition, so subdivision surface should be added, I think. To compensate the loss of the volume after subdividing it, I will select all the vertices, Ctrl A, and increase the thickness of the skin. I will do the same for this mesh, select it, Ctrl 1 to add the subdivision modifier with one level. Maybe crank it up to 2 or leave it at 1, and then Ctrl A while having all the vertices selected, and crank up the thickness. Imagine that the same process has been propagated to the right side with two circles there, and now we're pretty much ready to create the low poly alteration of the road block. Next, we need to somehow turn this 3+ million polygons model into a workable low poly version of it. We can go ahead and add the decimate modifier. Alternatively, it can be done in RC with using the Simplify tool, but I prefer to do all the mesh operations in Blender where possible. So what this modifier does is reducing or optimizing the face count based on the ratio slider. We can see the current face count read at the bottom of the modifier interface. Right now it reads 3 million. And as we drop down the ratio, the number of polygons will be crunched down according to that ratio. So the ratio of 0.01 resulted in approximately 30,000 faces. If we wish, we can do simplification in a few steps. So first, let's apply the decimate modifier and right away add it back. Now it should be slightly more responsive, so you can watch the effect in real time practically. Especially with the wireframe toggled on, it's very evident what's going on. And what should be the final amount of polygons depends on many things, on where you're gonna use it, on how you're gonna treat the textures, what features do you like to see preserved, especially when it comes to rendering of the silhouette. I think 3000 polygons for this model will be quite enough. It will be a peripheral asset, not super important, not a hero asset by all means, so 3K sounds good to me. One more checkup that I will do is enable face orientation within the viewport settings. That will allow us to see the flipped polygons in red. Haha, gotcha! Alt-N, flip. And here we have yet another one that should be flipped. Then we can merge the near duplicate vertices by pressing M and merging them at center like this. Maybe GG to slide some edges that were positioned dangerously close to other edges. And doing other mesh doctoring stuff, like deleting the stray vertices. Thankfully, they can be tracked and deleted automatically. We can do it by going into Select menu, then select All by Trait, Loose Geometry. That will pre-select all the stray vertices. Well, not all of them. I see that we need to adjust the selection manually. And then X and delete those vertices. Here we have another one. X, delete vertices. disable face orientation. I think it looks good enough to be exported as the low poly version of the road block. But before exporting the whole shebang to Reality Capture, let me quickly go over the alternative method of fixing the mesh for decimation. There was a problem with how decimate modifier plus the uneven density of polygons worked together. Let's enable the wireframe overlay and see what actually happens when we reduce the ratio slider. So after taking it down to 0.1, we can already tell that something is off with the way that the polygonal density works. But 0.01 really makes it evident, especially when the smooth shading is turned on. Because the bottom side of the roadblock has much less polygons on average than the rest of the mesh, after decimation it started to look a little bit awkward. Not that it matters too much for filler geometry, still it's worth exploring the ways of fixing it. So in the sculpting mode there's an intriguing brush called Simplify. The name potentially is slightly misleading because it can not only simplify or reduce the polygonal density, but also increase it. It should be used in conjunction with dynamic topology. And as far as the detailing method goes, I usually prefer to set it to constant detail. By default it's set to relative detail. And what this brush does is exactly changes the polygonal density underneath the brush stroke. And it's kind of awesome. The resolution can be controlled right there in Dynamic Topology Settings in the Resolution tab. If you don't want to do it manually by using brush, you can just press Detail Flood Fill. But make sure that detailing is set to constant detail. And if Blender didn't crash, and it probably won't anyway, it's pretty stable, you will notice that the entire mesh got covered in like even net of polygons. And when we feed this kind of input into Decimate modifier, it will naturally generate more evenly spread net of polygons in the output. So that's the alternative way of setting up the geometry for simplification. I will probably stick to the method that we used before, which is a slightly careless approach to geometry. But if you wish, you can go this slightly longer route. And also, if you wish, you can create the UV map straight in Blender. You can do it either in Blender or in Reality Capture, but if you wish to do it in Blender, first open the UV editor in one of the windows, then go into the Edit mode and select all the polygons by pressing the A shortcut, and then simply go U for bringing up the UV mapping menu and select Smart UV Project. The default settings work nice in most of the cases. One thing to keep in mind, considering the perspective of baking, is having some island margin present though. The island margin that is non-zero is fairly important in order to obtain a correct baking result without any artifacts, so it's definitely worth bumping it up ever so slightly before exporting it out from Blender. That being said, it is still an optional step. It can totally be skipped and done in Reality Capture instead, especially if you're gonna be baking in Reality Capture. If you're gonna be using XNormal or other baking application, then creating the UV map in Blender is must-have. One way or the other, the asset creation pipeline that we have chosen demands that we export both the high poly and low poly models out of Blender. I want to export the low poly model as one piece, so I'm selecting all the metal rings first, right-click, converting them to meshes to automatically apply all the modifiers, then shift-click on the roadblock and join it all together. We can check if it became a singular mesh in the edit mode like this. And everything looks correct to me. Now visiting the Object Data Properties menu for this object to make sure that we have enabled the Auto Smooth. Why no effect? Maybe we can right-click and select Shade Smooth, but then it's still pretty strange that the threshold slider isn't working. When it happens, it's usually because the custom split normal should be cleared in the Geometry Data tab like this, and then the slider becomes responsive again. From our experience, it's usually better to just smooth out or average all the normals. Alternatively, the weighted normals modifier can be used, but it's a little bit easier to just average it out. That is, if you're gonna be baking the normals from the high poly version of the model. Alright, so here is our simplified roadblock ready to be exported. It's ready to go, but first let's deal with the high poly version. It is in the scoped collection, so let's bring it in. Select everything. No need to join it this time. It will get joined on export. Then File, Export. I'm going to use the OBJ format as it's the safest one for RC. Selection only. The forward axis should be -X and the up should be Z. That is the settings for reality capture precisely. For other applications, it will be slightly different. For example, you shouldn't change anything if you want to bake in XNormal. I will put the high poly into its own folder, named accordingly to not forget where is what. And in just a second, I'm gonna do the same for the low poly. This is the collection. It is a singular mesh. Then again, File, Export, OBJ. Blender has memorized the settings, thanks goodness. Forward is -X, up is Z, everything looks correct. So we have taken everything out of Blender, and the next stop of our journey will be reprojecting textures in RC. By mesh doctoring both the high poly and low poly versions of the roadblock in Blender, we made the baking process so much easier. Hopefully. Let's give it a try. We need to bring it in. So let's get into the Mesh Model tab. Go straight to the Import Model. Navigate to the folder with the high poly _scoped and double click on it to import. RC will check the topology and hopefully fix the defects automatically. Sometimes it doesn't work as expected, but here it worked nicely, I think. We should recolorize the object because we used the dynamic topology and it erased the vertex color data. No big deal, it will survive the colorization process without hitch because we haven't changed the orientation of this mesh. It is positioned dead on. And let's import the low poly version now. It is in the corresponding folder. Cleaning the mesh topology defects, blah blah blah. It has to be renamed, obviously, because we're very pedantic about it, and unwrapped, that is, if we haven't done that in Blender. But anyway, we can just use the unwrap functionality of RC, just check its parameters. I think I set the maximal texture count to 1 before recording this tutorial, but it works for me because it's pretty convenient to have one texture set per mesh. Otherwise, it could be like 4 diffuse textures and 4 normal maps. It can quickly get out of hand. As for the large triangle removal threshold, I'm setting it to 100 to make sure that all polygons are unwrapped. Otherwise, the polygons that are larger than a certain threshold will not receive a usable UV mapping. And hitting the Unwrap button. To debug the freshly created UV map, it's worth applying the checkerboard texture on top of it. It looks pretty nice to me. The squares are fairly even. I don't see any heavily distorted parts or anything like that. Now we can do texture reprojection. It should be a surprisingly easy operation if we have imported everything correctly, and what is even more important, we have chosen the source and result model correctly. The color, the normal and the displacement reprojection both turned on. Now we should be good to go. And here we have it, my friends. Looks nice, except the bottom surface, obviously, for which the color texture is missing, as well as the normal texture. The rest should be fine, and we can check the individual textures by clicking on them in the left panel. We're halfway there, or even more, on our way to creating a workable asset. That's super exciting. Let's get back to Blender to finalize it. While this roadblock is already somewhat production ready, if you won't be showing the untextured parts, that is, we can still do better. Better than that. we can still do an absolutely 360 degrees solid model. We have gone through all the stages of production, from aligning images to exporting it out to Blender. We just need to persist through the last mile. I'm gonna put the low poly model with reprojected textures into its own folder, with the corresponding numeric prefix, obviously. Save mesh by parts, no thank you. What about textures? The textures maximal side, I don't see the point of going higher than 4K. Everything else looks okay to me. After spending a few minutes thoughtfully looking at the model, I realized that we could probably use texturing instead of colorization, for the high-density mesh, I mean. In theory, it could help us to bring in some more detalization, even though it's obviously not super practical to unwrap such a mesh consisting of millions of polygons. But anyway, the colorized and the textured version. Yeah, indeed. It's definitely worth it. So imagine that I have re-exported this version instead. I really did it, by the way. Really. Nothing is more tedious than going back and forth between two applications. That's what we are gonna do. But the result will be worth it. I promise. I promise. I'm creating a new collection, a cozy home for the freshly baked roadblock. Import FBX. Remember, we used the FBX format. Then choose the right file. Here it is. To double check if the textures have been hooked up correctly, I'm enabling the material preview mode and splitting the window in two in order to open the shader editor in the left one. Here we can double check the placement of the textures. We have just two nodes to watch for, not too much. The first one being the base color over there. And the second one, the normal map. I always do this little check up with normals. I break up, then restoring the connection. Looks magical. The setup is done. Let's think of how we can repaint the untextured areas now. There are a few ways of dealing with this horrible task, and we will have a look at all of them throughout the course. But here I'm going to use the base color texture that we already have to sample and clone the parts of it to fill in the untextured areas. First, I will disable the floor and X and Y axis visibility. Jump into the texture paint mode, where all will happen. And what we have to do is just paint on top of this texture somehow, preferably with cloning and reusing the parts of the original texture to save some time. T to open the left tool shelf. Pick the clone brush. Shift and right click to set the area for cloning. And actually, it will be somewhat easier if we set up the model in a somewhat strange way that will make sense in just a second. I'm gonna Shift D to duplicate the mesh, rotate it in such way so the surface with the writing on it faces our direction. Then, to preview only the base color, we can either choose the diffuse color as the render pass, or better yet, we can go over to the shader editor, hold Ctrl Shift and click on the base color texture. That will plug it automatically into the surface input of the material output, meaning that now we will be seeing only the base color texture without any influence of lighting. Then I will join these two meshes temporarily, because we can clone only from the same mesh. Right, Shift and right click to place the 3D cursor to where we want to sample from, and brush away. We still have the clone brush enabled. You can select it from the T menu on the left. So what I'm doing here is just treating this as a canvas in Photoshop or GIMP or Krita for that matter. And when I want to sample from the different areas of the mesh, not visible from this angle, I'm rotating the top mesh, if that makes sense. And then switching back to the texture paint mode and keeping the show going. It would be much better if Blender could clone from all the texture channels at once, including the normal map. We're working with the members of the Blender community and exploring different possibilities of how we can speed up that process, but no promises just yet. Alright, after cloning the texture, now you can see me sliding the vertices around to fix some pinched areas of the mesh, and then slapping some paint on top. I don't think I like the darker parts, even though they look somewhat nice and imitate the ambient occlusion, but still I think we can delight it somewhat. So I'm cloning over it as well. Once again, Shift and right mouse button sets the mouse cursor, which sets the sample area for the clone brush. Okay, once we're done, we can delete the redundant geometry that served as our stencil. Then proudly retreat to the object mode and watch what we have done. It is supposed to be the filler geometry with a filler texture, the bottom surface, so from that perspective I'm satisfied with it. Once we are done painting, we can get back to previewing the full material by Ctrl-Shift and clicking on the principled BSDF node in the shader editor. And that looks pretty nice. We will have a look at various ways of doing the same thing, basically, but that was one of the fastest and the most straightforward, even though not super functional at times, if we take the normals and other passes into consideration, that is. Aside from using the clone brush texture in Blender, which is fairly limited as we have seen, we can try using the projection technique. Because this technique relies on a display-referred content, it would be the safest bet to switch the view transform from Filmic, which is the default option, to Standard. It can be done in the Color Management tab. Then we need a camera, because we will be projecting the texture from a certain point and using a certain vector. So while having the camera selected, I'm pressing Ctrl-0 to make this camera active, then Shift and tilde on the keyboard to enter the first-person shooter navigation mode, and I'm aiming the camera right onto the object. The type of the camera can be orthographic within the camera settings to avoid any perspective distortion, and the orthographic scale set accordingly. As for the resolution, I won't be changing it right now because I think that the default 1080p will be quite enough, and we just need to render the image from the camera out and save it preferably as an uncompressed format, for example TIFF or PNG. After doing that, I will switch over to GIMP. You can use other image editing application if you like. I'll create a new layer, so we'll be painting only on that new layer and export it afterwards with transparency. And I will use the clone brush to erase the graffiti, for example. You can adjust the texture and inpaint anything you like there. It will be used for reprojection later on. So with only this new layer turned on, I'm going to export the image with transparency. Export as. The format should obviously support transparency, like for example, again, TIFF or PNG. I'm using TIFF there without saving any layers. And the point is that this image, excluding transparency, will get reprojected onto the original geometry in just a moment in Blender. So we prepared the image for reprojection. Let's load it up into Blender. In the image editor, I'm going to open it. Here we go. The transparency is still there, which is a good thing. Now switching over to the texture pane mode once again. And scrolling this menu until I get into the Tools options, the base color texture selected as the active one. Down in the Options tab, there is a pretty obscured menu called External, and from there we need to click Apply Camera Image and select the roadblock _01B that we have just inpainted in GIMP. And it got projected back onto the geometry. I'm pressing Ctrl-Z and Ctrl-Shift-Z to undo and redo the effect to compare before and after. So that's yet another method of adjusting the texture while referencing the parts of the original one. It's worth noting that after doing reprojection or any other manipulation like that, the texture, the base color texture, has to be saved once more. Otherwise we run into the risk of losing it on quitting Blender. That happens to me quite often. The images can be reprojected from different angles. So here I'm creating yet another camera by duplicating the first one, aiming it at our road block from slightly different perspective. I use the 3D cursor as the pivot point for the camera quite often while doing such tasks. And the idea is that we can proceed to inpainting the object from this direction and project it back once more, and so on and so forth. That was the second method of inpainting the corrupted base color texture in Blender. And now I owe you a few seconds of relaxation. Let's just look at the roadblock that we have just inpainted. Now you should feel relaxed. That is a nice asset we created together. We can take it to the next level, but only if you wish. And what I mean by next level is upscaling the textures using AI-based neural networks, or how is it called? It will be super exciting, so see you in the next video. In the previous video, we ended up creating this nice roadblock Photoscan 3D asset. I would happily use the assets like that in a game-like context. I think it passes the quality test. That being said, the base color texture is still on a blurry side, if you ask me, especially if it's gonna be used in the VFX context. So we can still try to crank it up to 11 out of 10 and pass the fairly low-resolution base color texture through the algorithms of neural network-based upscaling. You'll need a tool called Cupscale. It can be downloaded from GitHub, it's free. It needs a little bit of setup, namely installing all dependencies like Python and having a decent video card that supports CUDA. By the way, if you will have hard time installing dependencies, it can be done via the settings of the app. There's a button in there that says Install Dependencies. Right now, after some zoom in, we can definitely tell that there are blurry parts, and the effective resolution is not as high as the actual resolution that is revealed in numbers, meaning that we can probably render it out from that perspective in 40% of the resolution, or maybe slightly higher, in half of the resolution, and it will be the real effective resolution for that asset, taking the far from perfect lens of a mobile camera into account and other things that contributed to the blurriness. So let's try to upscale that low resolution image. I'm creating a separate folder for it and using the uncompressed TIFF format for storing it. It's 960 by 540 resolution, so let's mention it in the file name. Here's the Cupscale free application that can be downloaded from GitHub. What we need to do to upscale our low-res image is to drag and drop it into the central portion of the user interface, like that. And then choose the model of Generative Adversarial Neural Network, or GAN. Here we have 3 models, and after some testing, I had most success with the third one called Real ESR GAN. So let's go for it. The AI network to run should be chosen accordingly. So Real ESR GAN. As we had already adjusted the resolution of the image before importing it to Cupscale, we don't need to touch the resize before upscaling menus, and no need to adjust the resize after upscaling either. As far as the output module goes, I don't see TIFF there, so I'm gonna go with yet another uncompressed format, PNG. Then we can press Refresh Preview. Give it a few seconds. With a decent video card, it won't take long. Actually, it's surprisingly fast. It's only 8 seconds per image. You can click on the image to reveal before and after, and actually comparison looks striking. Even though the resized output can look, how should I put it, slightly more artificial, it still looks striking to me. Like how it imagines the details. Like, look at this hole. It's crazy. Too bad it doesn't work that good for normal maps and displacement maps. Now we can save the current merged preview, or press Upscale and save, and the file with the 4x resolution of the original one will be placed in the same folder. The glorious upscaled image for projection. Double checking it, here's the original 960 pixels wide file. And look at this, 3840 pixels wide, upscaled image. That's insane. Now back into Blender, let's load this image into Image Editor. Here it is. As we have mentioned before, too bad it doesn't work for normal maps and displacement maps because it was trained for different type of data, the neural network I mean. But even for the base color, it's pretty impressive. Look at this. Let's get into the texture painting mode. And in the right panel in the tool settings, let's find the Apply Camera Image button. Click on it, select the upscaled texture. Here is a quick before and after. Personally, I like the denoising side effect. I think it draws more attention to the highly defined edges, and that somehow contributes to the perception of upscaling. At least that's my impression of it. We can see this kind of a weird smearing effect at the side of the mesh, and it can be fixed in two ways. The first one involves GIMP again, or any other painting application. Only the opaque pixels get projected, so we can selectively make the pixels around the area that is meant for projection transparent. I'm using the eraser, and the brush is pretty smooth, so the fall-off is not as harsh as it was initially. It won't take long. After we're done, we can save it nearby or on top of the original image to not waste the file space. Export. Replace. Agree with everything. Now back to Blender. This image needs to be refreshed, the image for projection. So in the image editor and to open the right tool shelf, hit refresh. Enjoy the refreshed image, and now we can use it for reprojection once again. Back into the tool settings, in the texture paint mode, apply the camera image. Now we shouldn't see any weirdness, like any smearing at the sides. That's due to the transparency that doesn't contribute to projection. So it works pretty well. This projection method is fairly experimental, I must say. It may or may not work. The neural network may or may not understand and know how to upscale the image, so to speak. And it takes a fair bit of time to set up all the projections. Like, if the first one was the front projection, now we should do the left one, and then the top one, so on and so forth. I'm adjusting the orthographic scale and the camera position for the left projection. And then, as we remember, it needs to be rendered in half of the resolution, in our case, saved as the uncompressed TIFF or something, and super resized. Is there such word? Super scaled? Upresed in Cupscale, which is our neural network-based free resizing application found on GitHub. If we're lucky with our source images, the upscaled result should look somewhat like that, which is totally mind-boggling. I know it's a cliché in that world of neural networks, but it totally reminds me of the enhance command in movies. It's like going Cupscale enhance, and it churns out the image that is 10x the size of the original one, or 4x, never mind. It's actually pretty crazy. In the tests that I've run, it didn't work as well with the textures, like with the UV maps. And it's justifiable, I guess, because it wasn't trained this way. Okay, so I'm painting the transparency once again in GIMP. Probably this step can be avoided. I will show you the workaround. But anyway, I've just painted the transparency for the projection that we loosely call left. The compression to 0 to make it save faster. And at that speed of light back to our beloved 3D content creation application. Engage the texture paint mode. Head over to the tool settings. Make sure that the base color is still selected. And then apply the camera image with the new projection selected. I'm going to undo and redo a few times so we can see before and after. I love after much more than before. Like, look at this, it shouldn't be legal. How about the smearing effect? Yeah, we still see it. Even though we have had some transition between opaque and transparent pixels, it wasn't enough to avoid smearing. What can we do? Luckily, there is a little setting that helps with solving such issues, so if you scroll to the top like this, you'll find the normal fall-off tab. By changing the angle from 80 to, say, 20, you tell Blender to apply the normal fall-off, or to project only to the surfaces that diverge from this vector no more than by 20 degrees or something like that. And that means the surfaces that face the camera. So basically it should be alright now. So that was a pretty quirky, I must admit, but nevertheless super exciting method of upscaling textures in Blender by utilizing projection and free neural networks based application called Cubescale that can be downloaded from GitHub. I like this method in the context of photogrammetry and creating photoscanned 3D assets because it allows to extend the potential threshold of quality, even though this source material wasn't the highest quality possible, say it was captured on mobile. It suffered from lots of blur or lots of noise, and this method still opens the possibility of enhancing the quality in the end. Here we can see the result of the tutorial presented in Eevee. I think it looks pretty impressive. That was Gleb Alexandrov for CreativeShrimp.com. Thanks for watching our course. Welcome to yet another tutorial from Creating Photoscanned 3D Assets course, in which one we're gonna be exploring the techniques for in-studio scanning. And when I'm saying in studio, what I actually mean within the controlled environment with turntable and some lights. By the end of the tutorial, we should have something like this 360 degrees full model of a skull without any gaps and holes. In order to recreate the studio setting, we need some kind of a turntable. The stuff like that can be bought in the art stores. In addition to that, it's recommended to have a few light sources with soft boxes to create an even lighting. And if these conditions are met, we would be able to apply a cool little trick. Basically, we'll flip the photoscanned object along the way to get access to previously invisible areas like the bottom of the skull here. The process will look something like that. Without changing the camera angle radically, we'll use the rotating capabilities of turntable to get access to the object from different directions. And then the object is flipped on its side, and we pretend that the camera position changed, even though it's obviously a hack. By doing that, we will trick reality capture into thinking that two separate sets of photos with the object changed its position is in fact one photo set with the camera position changed. I hope it makes sense. This video will be split in two parts. In the first one, we will try our luck and just load up every photo from two photo sets all at once in reality capture and pretty much press the processing button. Hopefully it will be enough to trick reality capture into assembling everything into one mesh. Then if it didn't work, the second part of the video will be our plan B, in which we will explore a slightly more complicated technique involving masking in reality capture. Let's start with the easier and generally more enjoyable workflow. Maybe we won't need the plan B after all. So during the capturing session, we created two sets of photos. The first one with the skull being captured in this orientation, and the camera is changing its angle every now and then ever so slightly, but generally doesn't radically change the direction. And the second set is with the object being flipped on its side. And we do the same thing, but with the object being positioned slightly differently. Aside from that, it's just rotating the turntable pretty much. So I'm gonna drag these two folders at once in reality capture. Check the number of images, which should be 183. We can check that indeed we have imported all two folders there. And because it's a simplified version of the workflow, without further delay, I'm heading over to Alignment tab, checking the settings there. The image downscale set to 2, meaning the half of the resolution. What I'll do next is change the detector sensibility from medium if it was set to its default value to low. I found out that in order to sell two packs to reality capture as one, it's crucial to set the detector sensibility to low. After that, just press the align images as usual. Let's have a look what's going on. We got 4 stray cameras that have been put into its own component, which is not super good. And the component 1 is our main thing, nicely rendered. Even though it's a healthy number of cameras being matched, I think we could do better. So I'm gonna delete all the components and start from scratch. Settings, the image downscale factor, I'm bringing it up to 1, meaning no downscale whatsoever aside from the photos downscale that we have done in pre-production. Now in theory the result should be much better, more points to work with. Yeah, indeed, all the cameras have been matched. Perfect. The sweet type points in every image, meaning that the final mesh is doomed to be great. Doomed, if you know what I mean. And quaked as well. Next I will clear the render region to get the better view of the ground plane that I'm going to adjust right now. We can use the gizmo to carefully change the orientation of the object, and usually it's advisable to do it from the orthographic perspectives because it's just easier this way. So the top one, now the left, just nudging it ever so slightly, the front perspective, or rather projection. Looks fantastic. I'm going back into the perspective mode now and resetting the reconstruction region, like this. It is super satisfying to trick reality capture into meshing it all into one model without any gaps. It is fantastic. Just think about it, we don't have to do anything in post. Everything is done for us. So click on normal detail for the reconstruction to happen. Hopefully it won't reveal any new bugs, because sometimes it's hard to tell just by looking at the sparse point cloud what's really happening there. Here it worked without hitch, which is fantastic, I think. Just a minor glitch over there that can be lassoed out and filtered. So once we selected it, we can press filter selection. It will create a separate model without this part that we have just wiped out. And it is slightly awkward, because our plan A worked. Technically it means that the plan B is no longer necessary, but still I'm gonna record the plan B with using the masking to see how it works, where the situation is slightly more complicated than simply dumping everything into RC and pressing one button, right? So join me in exploring totally unnecessary but still pretty interesting part B with masking. Alright, so what do we do when reality capture actually persists in thinking that the object didn't remain static? What happens when it doesn't want to be cheated? Then the plan B kicks in. It is a slightly longer workflow, still worth exploring. In this case, we need to treat the sets separately, so here goes the first one with 76 photos. Let's align it right away. What we are going to do in just a second is render out a set of black and white mask images to go alongside the source 76 photos. I'm emphasizing the 76 number because it's fairly important for the reasons that will become clear in just a second. For generating the masks, we don't need high resolution. On the contrary, it's practical to be working in a fraction of the resolution, so I'm downscaling everything by the factor of 5, the depth maps I mean, and then reconstructing it all. So we got something like that, and everything except the hero object, which is the skull in this particular case, needs to be filtered out. It can be done by using the lasso tool, as usual. I'm carefully outlining everything but the skull, and then going filter. That is the mesh that will be used for rendering out the masks. Let's delete the first model that is unfiltered. Unfiltered like a beer. One of my favorite types of beer, by the way. So after having the unfiltered model deleted, I'm following it up by clicking on the depth and mask button, selecting the folder of the source photos. That is important to dump the mask files in there. Then silently agreeing with all the options proposed by RC except the export camera depths, which I'm setting to no. We don't need depths, just masks. And let's see how it gets rendered. After checking the folder with the source material, you'll find the masks in there. So far so good, we can move on to the second set. This file is no longer needed, it was just a proxy, so File, New. Where is our folder with the flipped skull? Bring it on. 107 images. Let's note this value somewhere too. And then follow through the steps that we have already explored. First, we match the camera position with pressing the Align Images button, and that creates a sparse point cloud. And then to generate the depth maps under the hood and flesh it out as a model, we press the Normal Detail button within the Mesh model menu. And in just a few seconds, due to the low resolution of the process, it delivers this kind of mesh, which is absolutely fine. We don't care about resolution at this point. We care about masking though, so everything that isn't the skull should be filtered out. There is still this part of the turntable visible, so I'm trying to carefully isolate it with the help of the lasso tool and get rid of it. After inspecting it from different angles really quickly, I think it's ready for extracting the masks, so we can proceed. Mesh model, depth and mask. Select the corresponding folder. OK. Everything at its default values. Press OK once more. And it's worth double checking in the folder if the masks have been generated indeed. And they were. Let the great merge begin. By taking the background out of the equation, or rather masking it out on the source photos, we force reality capture into thinking that all these photos belong to one photo session and the object as if hasn't been moved. You know, everything is relative after all. The camera could have been moved. After loading the first pack of images with the masks, we will notice that the number of images won't change. It still is displayed as 76 images. Then goes the second folder with 100+ images. And as we can tell, the masks got recognized as layers, so they don't contribute to the final score of the images. And voila! If there was no other option of merging these two photo sets together, masking would have done the trick. Well, at least in theory, but it's highly likely. So after seeing the merged point cloud and making sure everything is okay with it, I'm adjusting the ground plane, setting the reconstruction region, checking the mesh generation process settings, and setting the downscale to a higher value, because right now we're not generating the stuff for masking, but rather for the final quality. So cranking it up all the way to 1, which means 3K pixels wide or something like that, considering that the sources have been downscaled ever so slightly. To give it an aesthetic touch, we can colorize it, but first I will rename it Skull Poly. Press the colorize button. It goes too fast to brew a coffee in the process, I guess. And here we go, memento mori, my friend, and do computer graphics, that's my motto. What I find really impressive, and I mean it, is that there is no need for adjusting the model in post. Its full 360 degrees representation of the skull doesn't have any gaps that has to be closed. It can be simplified in order to obtain the low poly model like no problem at all. And this in-studio technique works great, I think. I'm really happy about it. I'm really happy that we don't have to go through the post-processing in this case. As a quick summary, this style of photo scanning in studio requires us to have some kind of a turntable solution, as well as the lighting that can be set up on stage. The more even it is, the better. Then, to avoid the need of post-processing, it applies a cool little trick. The photoscanned object gets turned on its side in the process of taking photos. And thanks to all things mentioned, it results in a full pseudo-spherical representation of the object. It works wonders for the medium and small size objects that we can actually carry to our home. And I hope you liked this tutorial from Creating the Photoscan 3D Environment Assets series. Hello creative shrimps, Gleb Alexandrov here, welcome to yet another tutorial from the photogrammetry course. I'm pretty excited because in this video we'll explore the photogrammetry workflow, which is 100% open source and cross-platform. Before we begin, that's the software that we're gonna use, so feel free to download it. Darktable for pre-processing the raw files, Meshroom as our main photogrammetry tool for this tutorial, and Blender obviously as a multi-purpose 3D editing tool for cleaning up the mesh and baking textures. A quick disclaimer though, it might be not the most optimal photoscanning workflow. There are tools and applications that are simply faster than Meshroom and say more convenient than Blender when it comes to baking, but it's definitely the most accessible photogrammetry workflow at the moment, so let's get started. Here is a brief introduction to what the capturing process looked like. So we went to this abandoned post-Soviet hangar, found this amazing cellophane and pretty much shoot it from all possible angles while following the best practices of photogrammetry, mainly keeping the ISO at its lowest number, setting the f-stop to 8 to make sure everything is in focus, and then using tripod to calibrate the shutter speed as we like it. When shooting on tripod, the shutter speed can be any number we like, no shaky hands involved. But to stay on the safe side, we set the timer to 2 seconds as well to reduce the camera shake on pressing the button. That is pretty much it for the photo session. We have covered these settings extensively in the first chapter of the course. Oh, and we also took one photo of our X-Rite color checker gray card to be able to calibrate the white balance in post. The whole scan took 107 photos on Canon 80D with Sigma 17 to 55mm lens. The source photos as well as the blend files are available for download, so if you want to follow along with us, consider downloading these photos. Before starting the photogrammetry process, let's actually process the raw sources in Darktable, a free and open source software for developing the raw files. So right away, I'm gonna open the folder with all the photos that we have taken during the scanning session, and then I'm simply dragging it into the central window of Darktable. If you don't have the panel on the left, you can hit the triangle to open it up, and there we can check the metadata or the image information. There is a lot of interesting data in there. What were the camera settings? For example, f-stop was set to 8, apparently, exposure at 1/2 of a second. The ISO is just 100, which is awesome. And it never hurts to double check if it's the RAW file indeed, which it is. We can tell it by the CR2 format. On the right, we should also have the open panel with history stack and export settings. Right now we're in the light table mode, in which we simply preview all of our images, and we edit them in Darkroom. You can access it by double-clicking on any image. Let it be the image with the gray card that will serve as a reference. Down in the Modules tab, I will activate all modules just for a second to showcase something. The thing we should watch for when developing the raw files in Darktable is whether the base curve has been disabled. Occasionally you may discover that some kind of preset has been applied. These curves are similar to the in-camera processing that is applied automatically when you shoot in JPEGs, and that's something that we should avoid when shooting in RAW, so here goes the reset button. We should keep the contrast curve linear, or disable it altogether. Alright, now I'm visiting the Modules drop-down menu and selecting the Scene-Referred Workflow. That's the preset that contains all the modules that we'll need in this tutorial. And next I'm going to check the tabs at the top of the shelf to make sure that pretty much all the modules have been disabled. And it seems like it is the case, except the Filmic RGB that should be also turned off, because it also implements a kind of a curve, and we should be suspicious about any kind of curves when developing our raw data for photogrammetry. In other words, we're trying to stick to the sensor values as close as we can and avoid the transformation that are meant for display. So to calibrate the colors and make them closer to the reference in the source photo, we should adjust the white balance first, the temperature slider. Thankfully, we have the gray card in our scene, so we can set the custom white balance, with the help of such card. If you don't have a card though, don't despair. Try to find the area in the photo that is supposed to be as close to neutral gray as possible and select it, or it's always possible to eyeball it a little bit. So here we have the scene illuminant that is approximately 6K kelvins. What we can do next is adjust the exposure in a similar way, because we have the 18% gray card, and we can use the color picker tool in Darktable to read the lab values of these pixels right here. And this value, according to the specification of the X-Rite color checker, should read as 50 in the lab terms. To double down, we know it for a fact that if we want to align these values with the values of the color checker, which is our reference, it should read 50. So what I'm doing here is carefully nudging the exposure value to the right, and then clicking on the color checker and checking again, increasing the exposure a bit more. 44, close enough to 50. Now I'm going to enable the tone equalizer module to try to reduce the influence of the light sources on the scene. We can do it in two ways. We can, of course, adjust the sliders, like the 0 EV slider here, or we can hover the mouse cursor over some area of the image and use mouse wheel to adjust the sliders. Something like that. It's not a physically correct operation, and it shouldn't replace a proper delighting, but that's a decent starting point for pre-processing photos for photogrammetry. I usually follow it up by switching the highlight reconstruction to reconstruct color. That's an additional measure to preserve some highlights that otherwise will get clipped. Alright, getting back to Lighttable where we have all our photos arranged. So we have adjusted this particular image. Now down in the history stack I'm pressing selective copy, making sure that the white balance is included. That's important. And pressing OK. Now Ctrl A to select all images at once. In the history stack, selective paste, and happily confirm the operation. The adjustments made to the photo with the color checker should now propagate to the rest of the sources. It looks good to me, I think. Now we should be ready to export this batch of images out of Darktable. So I'm heading over to the Export tab, pressing the Browse icon. I've created two folders in advance, one for geometry and the other one for texture, and they are called like that: Mushroom Geometry, Mushroom Texture. I'll explain why in just a moment. So let's enter the texture folder, set it as the output destination, and now we should check two things. The first one is the output resolution, and I'm limiting it to 2500 pixels wide. Why do we do it though? Why not simply use the full resolution? Firstly, to reduce the processing times, secondly, to reduce the file size, and finally, and probably most importantly, we found out that prescaling the footage before feeding it into Mushroom leads to better results than using the higher downscale factors within Mushroom. And then we should check the file format, that should be 8-bit TIFF, and hit export then. After this batch of images meant for texturing have been exported, let's do another batch for geometry. Disclaimer, this step is not absolutely necessary. Mushroom will work just fine with just one set that we have prepared already. That being said, it's very useful to know how to prepare the split input for geometry and textures in Mushroom, so that's what we're gonna do. Double-click on any of the sources to enter the darkroom mode. This time I will prepare the more contrasted versions of the image, so tone equalizer set to off, the local contrast can be set to on instead. I'll try to boost the overall sharpness and the amount of fine detail in the images. In theory, that should help Mushroom to reconstruct the better mesh. So let us also enable the sharpen effect, crank up the amount all the way to 2 to its maximal value. Not that the whole process wouldn't work without all these sharpening shenanigans, but anyway, it's useful to explore this branching workflow of feeding two types of sources to Mushroom. So once again, click on Lighttable to get back to our Lighttable tab with all the previews. Selectively copying all the settings, including white balance. Ctrl A to expand the selection to all photos, and then selective paste all modules onto them. Looks like the processing has been finished, so we just have to export it out to its separate folder. Clicking on the Browse icon, back to the folder. And now let's dump it into the Mushroom Geometry folder. It is important that the resolution or the size of the images line up with the previous folder, so 2500, and pressing the export button. After pre-processing the raw files in Darktable, we should have two folders. The one with the images calibrated for texturing based on the reference gray card. Don't worry if it looks a little bit too flat and boring. It should look like this. It is meant for albedo textures. And here's the second one with the files aimed at reconstructing geometry, slightly sharpened, with boosted contrast and so on. Right, so we did all the pre-processing required for photogrammetry in Darktable, and now we can actually move on to Meshroom and start the photogrammetry process going. Now on to reconstructing a fabulous 3D model out of the processed photos in Meshroom. Before we get started, feel free to download this free and open source photogrammetry software from lsvision.org. So the first thing we need to do is import the photos that we processed in Darktable into Meshroom. In order to do that, I'm gonna select the photos from the geometry folder and drag them onto the images window. So once we load up our source photos into Meshroom, we should see it over there. The scale of the thumbnails can be changed if we wish. So these are the photos that we have pre-processed for geometry. We can click this icon to check their metadata and see if everything is alright. For example, it's worth checking the resolution to see if those files are the files that we think they are. Looks okay to me. And now we can press this enticing green button that says Start. Actually, no. We should really use nodes one by one in the graph editor. It's much safer to approach Meshroom in a modular way and activate these nodes one by one until we reach the final destination, which is the texturing node. That's gonna be the last one. But we should be definitely proceeding through this chain on a node-by-node basis. So I'm gonna right-click on the first node and compute it. Meshroom prompts an error that we should probably save the file first, so let's heed the advice. File, save as, name the file somehow. I won't be insisting on particular naming. Okay, now we can right-click and compute it again, and we can see that the progress bar became green. It means that the node has been calculated. Every node in Meshroom has the attributes that can be changed, and some of them can be seen only if the Advanced Attributes checkbox is ticked. But at the same time, this checkbox makes everything convoluted, and the default settings are more than enough in practically all cases. But at the same time, there are some useful settings that can be seen only with this checkbox set to on. For example, the Force CPU Extraction checkbox, which can be switched off for a slight benefit in speed, but generally it isn't that important to see all the advanced attributes. Well, okay, returning for a moment to describer density and describer quality, these two settings definitely have the most influence over the processing time and the resulting quality of the feature extraction node. I will go with the flow or with their default values, but feel free to experiment. The right-click menu, compute. The progress bar on the node has turned orange, meaning it's processing. Once it's finished, it will turn green, and that's how we know that it's fully processed. Now, for example, we know that every feature has been processed. We can click on the Display Features icon in the image viewer to see those markers or sift features. Basically, Meshroom detected a bunch of points for every photo, and in the feature matching node, these points will be matched to then create the structure from motion. But first, let's compute the image matching node, then proceed to feature matching. No need to touch the settings. The default values are just fine for these nodes, probably all the way until the depth map node, based on our experience. So right-click, compute. To track the progress, we can head over to the log window, and we will see the chunks there. Each chunk has to be processed until the node is calculated and marked green. And here we can see the progress bar for each chunk as well. The chunks, just like the nodes, are also marked green on finishing. So it took approximately 7 minutes to calculate the feature matching node. I'll be logging the progress, just in case. Then onto the structure from motion node. As you can see, the calculations become progressively longer and longer, and this node definitely will take a considerable chunk of time. 20 minutes to be exact. Wow. It's quite typical for photogrammetry and for mushroom photogrammetry too, of course. I feel there might be an opportunity to use a wise quote here. To lose patience is to lose the battle, by Gandhi or something like that anyway. But what do we have here? It's our structure from motion that has just finished processing. Alright, we can see the generated result in the right-hand panel. The visibility can be toggled on and off by pressing the eye icon. We can read the number of points there and the number of cameras that have been matched. 107. All cameras have been matched, and that's great. Then in the top right corner of the UI, we can change the scale of the points and the scale of the cameras as well. I try to keep these values pretty low so the viewport doesn't look as cluttered. Alright, by looking at the viewport, we can tell that the orientation of the model is a bit weird. What we can do is add the extra node after structure from motion. In order to do that, we need to create some room. So I'm gonna move it like this to the right, node by node, until we free up some space over there so we can plug the node. Right-click on the empty space, go Utils, SFM Transform. The SFM data should go into the input, and then right-click and remove this existing connection and hook up the output SFM data file to SFM data input of the prepared dense scene node. We can choose from different transformation methods, but let's try auto from landmarks. Hopefully that will fix the orientation issue. Let's compute the node, double-click it to open it up. Let's toggle off the visibility of the original structure from motion, and I think something is wrong. Let's try unticking the scale and translation checkboxes and just play with rotation instead. Okay, double-click again. Alright, awesome, that did the trick. I think it improved the orientation of the point cloud. It's far from perfect, though. I think it can be adjusted furthermore. Say, if we'd like to tweak the orientation of the point cloud manually, we can do it too with the help of the SFM transform node. So I'm gonna repeat a somewhat tedious process of moving it node by node to the right, and then I'll hook up the second SFM transform node in between these two. Something like that. The transformation method now should be set to manual. That gives us a gizmo with scaling, rotation and translation controls, so we can place the mesh, or rather the point cloud, manually somewhere in the scene. Let's toggle off the visibility of the original object and use the gizmo to carefully rotate and translate the mesh until it rests on the grid, like this. There are two gizmos now, one for navigating in the viewport and the second one for rotating the mesh. You can click on this hide gizmo icon to hide it temporarily. Optionally, this alignment step can be skipped altogether, because we will be tweaking the orientation of the resulting model in Blender anyway, but I'm too pedantic to skip it. I really want to see the correctly oriented mesh right here, right now in Meshroom. Alright, after doing the quick alignment, we can proceed to calculating the rest of the chain. Preparing the dense scene for depth maps won't take long, just a few seconds at max. But then it's time for the depth map calculation. That beast can definitely take an insane amount of time, especially if the downscale is left at 1, meaning the original resolution. In other words, if the downscale is set to 1, Meshroom divides the source photo resolution by 1, meaning it uses the originals. If the downscale was set to 2, Meshroom would divide the resolution of the source photos by 2 before processing the depth maps. If the factor becomes 4, Meshroom downscales it furthermore. Now it is a rhyme. Let us go with the downscale of 2 though, taking into consideration the already halved resolution in Darktable though. So by taking that into account, it's like 4x optimization already. In addition to that, there is a whole bunch of advanced parameters which I really don't recommend touching, and the developers of Meshroom don't recommend tweaking it as well. So let's listen to them. It's simply not worth it. Alright, calculating the depth map now. There should be enough time for a cup of coffee or green tea if you're up for it. In order to predict how long it will take, we can once again check the log. Each chunk that has been processed shows the time that it took. So to approximate the remaining time in a kind of a rough way, we can multiply the time as seen in the finished chunks by the total number of chunks. For example, we can tell that the depth map chunk number 12 took approximately 19 seconds to complete. And then let's say we have 35 chunks in total. That means 19 multiplied by 35. What is it? 660 seconds or 11 minutes. It is a very rough ballpark though, because chunks can take different time to calculate, but that gives us some figure to work with. Allow me to fast track the result though. Anyway, it took about 11 minutes indeed. I think it's actually pretty fast because we have downscaled the sources in Darktable, remember? That is so totally worth it, downscaling. If you feel like waiting a little bit longer, and potentially getting more detailed result in the end, then just feel free to bump the downscale value all the way to 1. It is a little bit scary though. Anyway, I'll proceed to calculating the depth map filter node, which is really quick to calculate as opposed to the depth map node. Alright, so with the depth map calculated and filtered, it is a high time for materializing the 3D model itself. The colorized output can be turned on if you want to check the vertex colors, but I don't see a real need for it right now. Then we should probably consider switching on the custom bounding box within the meshing settings. That would really help to cut the garbage and optimize the reconstruction speed. Right away we see no change after ticking this checkbox. That's because we need to double click on the meshing node, that's important. And then we should see this new model in the scene tab. And we can hide the bounding box if needed by clicking on this icon. Alright, so we can adjust the reconstruction region by manipulating this gizmo, but it's somewhat obstructed by this second display gizmo. Thankfully we can disable it by clicking on the display trackball icon. And now we can move, rotate and scale this thing so the bounding box encapsulates our mesh in the most optimal way. Like, do we really need to render everything or just this clothy object? Maybe we can save some resources by constraining it like that. Sometimes it's a life-saving optimization if, for example, you have scanned the entire city area and you want to render just this building. Okay, with the bounding box ready, we can go ahead with the mesh reconstruction. That is pretty exciting. We will see the fully-fledged photoscan, the fully-fledged 3D object for the first time, and we will tell if it's good or not. Of course, I already know that, but anyway. I will disable the bounding box, re-enable the trackball in the viewport, and what can I tell? Except these floaters at the bottom of the model, everything else looks great to me. Actually, better than I expected. This is our photoscan, and it is actually good. I'm really happy with it. Now we can either proceed to the very end of the chain and do texturing, or we can do the cleanup in Blender and then do texturing instead. And that's probably what I'm gonna do, because I want to change a few things with the mesh. So after creating the publish node, I'm connecting the mesh output into the input files, and then the output folder needs to be selected. We can do it like this, at least in Windows. After opening the folder, right-click on its name, copy address as text, and then paste the text over there in the output folder field. And lastly, right-click on the node and compute. After that, an OBJ file that contains our high-poly mesh should appear in that folder. In just a moment, we will bring it into Blender for some cleanup. In this part of the video, we're gonna mesh doctor our 3D model in Blender and then bring it back to Meshroom for some texturing. So fire up Blender, go File, Import, choose OBJ, navigate to the folder with the model, and hit Import. So that is our mesh, but before doing anything with it, I'm gonna right-click in the bottom of the user interface and enable Scene Statistics. So we can see that it's approximately 1 million vertices and 2 million faces. And, well, it seems that the Z-axis was flipped. We thought that we sorted out the orientation, but not as fast. It isn't recommended to change the mesh orientation itself, because it has to be re-exported back to Meshroom, so I created the empty object instead. I'm gonna parent our mesh to this empty object. Select both objects, with the empty being the last one. Right-click, parent, object. Now, on rotating the empty objects, the mesh will follow all the changes in transform. And in addition to that, our empty will record the changes that we do, so we can roll it back just before exporting it out, so then it all aligns perfectly with the mesh from coordinates. Okay, next I will add the cylinder that will serve as the boolean cutout object. Let's crank up the vertices count to make the cutout a little bit smoother. We can click the X-ray icon to see through things, and S and X to scale the cylinder horizontally on the X-axis. And then I'm going to select the photoscanned asset, come over to the modifiers tab and choose the boolean modifier. Right away I will switch it over to the fast mode, because well, it's fast and we're dealing with considerable number of polygons, and the mode should be switched to intersect instead of difference. Then I'm going to pick the cylinder as the operand, and that constrains the asset to the shape of the cylinder. Now we just have to apply the modifier, and lastly we can select the boolean object, press X and get rid of it, and toggle off the X-ray mode. Alright, so technically what we did is just imported this photoscan into Blender, modified it. We could have edited the mesh itself or applied any kind of modifier or adjusted it via sculpting, for example. It doesn't matter much at this stage. What we did is made some change to the mesh, but because we have the empty object around, we can revert the transform of the object and get it back to reality capture for some texture projection, for example. Alright, so far so good. Should we show some sculpting techniques though that may come in handy? What do you think? Alright, I think we can take this risk and stretch this section a bit more to show how the mesh can be cleaned up via sculpting, just in principle, you know. By the way, now I will save this blend file to load it up once we mess it with sculpting. Just keep in mind that this sculpting section is not supposed to be followed along, or you can obviously do it if you wish, but be sure to save the file so we can get back to it. Often, if the photoscan is good enough, cleaning it up means denoising it. The high-frequency perturbations in the geometry is the scourge of photoscans, and the Blender sculpting mode comes to the rescue. In the left tool shelf we can find all the brushes, and if the mesh is dense enough we don't need dynamic topology, and I think 1.7 million polygons is already dense enough. And now, what brushes could be useful for denoising the geometry? The flatten brush comes to mind instantly. It's my favorite brush for this kind of task. It works in kind of a simple way. It really does flatten the geometry. It can't be put better than that. The strength can be controlled at the top of the user interface, and that's especially useful if you do it with mouse. If you use tablet, the strength can be controlled via the touch intensity. And needless to say, that makes the whole process much more intuitive and just generally faster. And then you just gently massage the mesh along its curves, and the flatten brush is intelligent enough to not wipe out all the detalization in those places. That is my #1 brush when it comes to manual mesh denoising. It's really, really good. Then we have the smooth brush that can alternatively be invoked with the help of the Shift hotkey with any kind of brush. It is even more nuclear than the flatten brush, so you have to control the strength if you don't want to transform everything into marshmallow. But in small doses, that's also a nice medicine for the noise. The third brush which you can place roughly in this denoising section is the scrape brush. Actually, the settings for all the brushes can be found in this menu. Say, if you want to adjust the radius, the fall-off, the strength, the direction, the texture, whatever else, it can be done from this menu. You can explore it if you wish. So even though the scrape brush works kind of similar to the flatten brush in terms of polishing the surface, it has the very strong hard surface connotations. Imagine having to clean the photoscan of some mechanically engineered surface, something along these lines. It's a fairly unique brush, and it fulfills this unique role. It's very easy to overdo it though, so I would be careful with using it. Again, maybe in cleaning up the mechanical surfaces it has its place, but it's a little bit, you know, freestyle. So the flatten brush is super useful for reducing the noise, the smooth brush, then probably the scrape brush from time to time. If the photoscanned mesh has some really cursed spot that has to be filled with concrete, then the clay brush may come in handy. It literally builds up the virtual material in crevices so we can fill the entire caverns of chaos with this clay. And sometimes it's the last resort. It's the last thing that we can do to clean up the photoscan mesh. Now loading up our backup as promised. What I recommend to do with such meshes is just give it a slight treatment of the flatten brush. By the way, the tool shelf with the brushes can be toggled with the help of the T shortcut. So what I'll do here is apply a small and fairly insignificant layer of flattening with the flattened brush, obviously. I will fast track this to not bore you to death. At this point, I want to encourage you to try the sculpting brushes, the flattened brush specifically, to see what you can squeeze out of this mesh in terms of quality. And once you play it with the baking tools, we can export this cleaned up and sculpted mesh back to Meshroom for some texture reprojection. Alright, so let's imagine that we have done everything that we wanted to do with this mesh. We trimmed it, we sculpted it out ever so slightly. What we need to do now is open the right tool shelf with the Transform tab and reset the rotation of the empty. As we remember, all the changes in orientation have been recorded in there, so let's input 0 in the X rotation field and that will bring it back to its original value. If we did everything right, after exporting this mesh out back to Meshroom, it should align perfectly with the previous parameters. So I'm using the OBJ export once more, creating a separate folder for it called Hypoly Tweaked. Limit the OBJ export to selection only. The other properties should be left at their default values within the Geometry tab. And I think we should be good to go. Maybe after renaming it. Hypoly Tweaked. After successfully exporting it out, we can press Ctrl Z a few times to undo a few steps and bring back the rotated version of the empty. Chances are, we may want to return to this file later on and fix something. After our mesh has been cleaned up in Blender, it's time to return back home into Meshroom and do some more texturing. We don't need the Publish node anymore, so I'm gonna hit Delete. Now we have mesh filtering and texturing nodes to do. Let's push them over to the right like this to free up some space here. Then I'm gonna right-click, go Mesh Processing and add the Mesh Decimate node. This node will be our workaround to actually load the OBJ mesh from Blender. Otherwise, we'll simply get an error that I'll show in a moment. So I'm removing the connection that was previously going into the mesh input of mesh filtering and reconnecting the output of Mesh Decimate instead. Next, we're going to define the input of our freshly created OBJ file here. So I'm going to drag it over there. Let's also set the simplification factor to something insignificant like 0.99, just for the purpose of reworking the vertices of the mesh, basically. Right-click, compute. As I've said, we need to do it like this, because for some reason mesh filtering node doesn't accept our mesh. I don't know why, really. It could be a bug. Actually, let's try it out. I'm gonna paste the path to the OBJ file into the mesh filtering mesh input and try to calculate it. And boom, the progress bar turned terrifying red. So that's why we needed to pre-process the mesh via the Mesh Decimate node first. So I'm setting the smoothing iteration to 1 in mesh filtering for some extra polish, and now it should be perfectly fine. I think it could be a bug of how Blender exports the OBJ files, or at the same time it could be a bug with how Meshroom interprets them. But anyway, now we know the workaround. Double-clicking on the mesh filtering node opens it up in the right panel. I think it is worth hiding the rest of the meshes to get a clear view on our new one. It's ready for texturing, I think. Before feeding in the second set of inputs specifically designed for texturing, let's try to process this node as is to show something. Namely, to show how the texture file type set to TIFF will look like, and generally to show how the overly sharpened file with cranked up contrast will look like. Hint, not great, not terrible, but you will definitely see the color management issue related to TIFFs. So double-click on texturing to preview it in the viewport, and if for some reason you don't see textures, it can be switched on in this menu. So as you can see, the diffuse texture turned out to be significantly visually darker than our input photos, in addition to weird contrast and sharpening that we did for better processing of geometry. That is related to how Mushroom does color management. Specifically, it used an EXR format under the hood for pre-processing the sources. And now, after spotting TIFF as a texture file type within texturing node, it basically converted everything to sRGB color space. But what would be the safer workaround to avoid any confusion with color profiles and stuff like that? We're going to sort it out in a moment. For now, let's right-click on the texturing and duplicate this node. Let's sort out two issues at once. First of all, let's connect the inputs designed for texturing into this node. And secondly, let's untangle the color management puzzle. In order to branch texturing like this, we would want to have two copies of prepared and seen node. So what can we do is duplicate this node and have a look at its settings. It should have the images folders drop-down menu where we can hit the plus icon and define the path to the folder with the sources meant for texturing. As a quick reminder, we had two folders, one for geometry, the second one for textures. The one for generating diffuse and later on albedo texture was slightly flat looking and as if deleted already. This one. Let me copy the address as text, Alt-Tab into Mushroom and paste it over here. Next, it would be brilliant if we connected the images folder output of this node all the way to the corresponding input of our second texturing node, if that makes sense. To cut the connection, I'm going to right-click on it and choose Remove. I hope the user interface is big enough in order to see it. Anyway, now we need to connect the images folder input and output like this. It's important to not mess the connection somehow, and it is hellishly easy to do that actually. We need to be extremely careful with nodes. As for the settings, let's keep the texture side at 4K resolution. We can go slightly higher if we wish to, but I think 4K would be quite enough. The downscale at 1, meaning original resolution, and the texture file type to EXR instead of TIFF. Lastly, the unwrap method should be set to LSCM, otherwise Mushroom will generate a whole bunch of textures, like 10 textures instead of 1, and I think we would like to see the texture nicely packed into one file. It took approximately 10 minutes to generate the texture, which is not that bad. Let's double-click it to load up the preview in the viewport. Let's hide the stuff that is blocking the view. And here it is. An amazing high poly mesh with UV map and diffuse texture ready to go. It took us approximately 47 minutes to fully calculate this photo scan with texture in Mushroom, and actually I'm really satisfied with the quality. Maybe not so much with the processing time though. I wonder, what do you guys think? In my opinion, it's pretty good and usable as an asset, especially considering that's the free and open source pipeline. That is by itself mind-blowing, I think. As a finishing touch, let's take the model plus texture out of Mushroom via the publish node. The mesh and the texture as well should go into the input files. As usual, the output folder has to be defined. Let me create a separate one called High Poly Textured and just drag it into that window. Right click, go compute, and there it should be dumped into that folder that we have just defined. And indeed it is there. Perfect! So that is it for the first major part of the tutorial, where we managed to generate a pretty good photoscan mesh using 100% free open source and cross-platform pipeline. In the second part though, we'll take this model and make it game ready by baking textures onto the low poly version of this model. Hello and welcome to the second part of the free photogrammetry pipeline tutorial, in which we explore the 100% open source, accessible and cross-platform pipeline for creating amazing photorealistic 3D from photos. In the previous video, we used Darktable to develop our raw photos and Mushroom to generate 3D geometry. We also utilized Blender as a general cleanup tool. And in this video, we'll use Blender as a baking tool to reproject diffuse, normal, and even displacement textures onto the low poly version of the mesh to make it game ready. As a refresher, that's how our raw scan made in Mushroom looks imported in Blender. You can find this file in the project files, feel free to download it. So currently this mesh is fairly heavy. It has 1.7 million triangles, and faces for that matter, because it was triangulated. And once again, both the blend files and the OBJ file used for this tutorial can be downloaded. We'll require these files in just a moment to be able to follow along, so it's recommended to get it. So I think we're ready to start our Blender baking adventure. First we'll need to go over to our import menu to get the OBJ file in. Click import. It could take a few seconds if it's heavy enough, but here we go. I'm gonna rotate the model so it sits on top of the grid, and to aid the rotation I usually set the origin to geometry from the right click menu, and then it's the usual business of snapping the object into place by utilizing G, R and S hotkeys for grabbing, rotating and scaling it. And it's easier done in the orthographic projections that can be brought up by the help of the numpad keys. Next, we should probably smooth out the normals of the object, so right-click, Shade Smooth. Actually, it's fairly important to keep the normals averaged or smoothed out before any kind of texture projection. To organize the scene a little bit and prepare it for baking, I'm going to create a new collection and call it HP or High Poly. And while we are at it, let's also rename the object accordingly. So High Poly is the name. As you remember, we have had the diffuse texture somewhere. Let's hook it up to the principled BSDF shader. So here is the shader editor, and let's drag our EXR texture into it and plug it into the base color socket of the material. By the way, the color space is still set to linear, or it could be non-color, that's the same thing. Now to be able to see this texture, we need to jump into the rendered mode in the viewport. Maybe I'll also increase the strength of the environment light. Alright, so the high poly version is approximately 1,700,000 triangles, or faces. Our next mission objective is to derive the low poly version by simplifying this monster. That's our plan. Let's duplicate the mesh and crunch down the density of polygons considerably. I'm renaming this object to low poly and putting it into its own collection called LP. Probably the easiest way to turn the high poly version into its low poly counterpart is to utilize the decimate modifier. If you have a look at the modifier settings, you will see the face count displayed at the bottom. Right now it reads 1,700,000 polys. If we enable the wireframe, we'll probably have a better taste or better look at how we crunch down the poly count. So the ratio of 0.1 reduces the poly count by the factor of 10, obviously, and what I usually like to do is apply the modifier and then add the second iteration of it. So modifiers, decimate. By doing it like that, we make sure that it behaves in a more responsive and fluent way generally, and it's just easier to fine-tune, I guess. So, reducing the ratio down to 0.05 or even 0.03 produces 5K faces. That should be totally fine even for real-time applications, I think. Removing the material just in case. And before giving it a green light, it's useful to preview it in the solid shading mode. I see some mesh artifacts that bother me, so I'm gonna increase the ratio ever so slightly and apply the second iteration of the decimate modifier. So this is gonna be our optimized version of the model with the face count of approximately 7,000 triangles. That should be an okay poly count for the modern game engine, kind of an average one for this type of an asset, I think. So now it boils down to making it look as cool and as high poly, I guess, as possible. You guessed it, via baking. There's just one more thing left to do before actually baking the textures. It is creating the UV map. So in the second window, I'm opening up the UV editor, selecting all the faces in the edit mode with the help of the A shortcut, Then pressing U and selecting Smart UV Project as the fastest unwrap option, almost an automatic one. The defaults should be fine, let's confirm. After seeing this huge island that represents the ground, I think we can select it by pressing L, then S to scale it down a bit actually. And then select everything by pressing A, go UV, and let's pack it. Now the UV space is used in a slightly more efficient way that prioritizes the object and not the ground. Even though it's not perfect, it's much better this way. Now, when our low poly model has been successfully unwrapped, we can figuratively put it in the oven for baking. In the oven. Anyway. Alright, to keep the workflow free and open source, we're gonna be using Blender for baking textures in this part of the tutorial. It has a few minor quirks, but it's totally doable. So first of all, I'm gonna toggle off the visibility of our high poly mesh in the outliner and enable the collection with the low poly mesh instead. As a quick reminder, it has been simplified to approximately 7,000 faces, and the UV map has been already generated as well. So our cunning plan for making the displacement map from multi-res in Blender looks like this. First, we need to capture the details from the high poly mesh by adding the multi-res modifier and the shrink wrap modifier. That's our magic combo. We'll subdivide our multi-res a few times to give it enough resolution, then the shrink wrap modifier will capture the geometric details from our source high poly object, and then eventually these captured details will get pushed into the multi-res again so we can bake it as a height map. Don't worry if it doesn't make sense just yet, we'll get into the weeds in just a moment and we'll show the whole process. For now, let's actually don't forget to select the high poly mesh as the target for shrink wrap. To capture the full range of surface intricacies, we should probably bump the resolution within the multi-res modifier. So I'm gonna click Subdivide, and that will increase the resolution of the geometry. And you can already see by its changing shape that it inherited the detail from the high poly mesh. That's shrink wrap doing its magic. So let's subdivide it once more for even better effect. And it's looking quite good already. Let's check how many polygons did the original model have. 1.7 million. So that is our target. That is the reference number of polygons we should drive our low poly multi-res geometry to. Or rather triangles, because the low poly model hasn't been triangulated yet. So currently it measures approximately 81,000 faces and 163,000 triangles conversely. So ideally the number of triangles after we subdivide it a couple more times should correspond to or be higher than the number of polygons in the reference model. So let's click Subdivide once again within the multi-res modifier and let's see what the poly count will become. Alright, we got approximately 300,000 faces, not nearly enough, so let's try our luck at subdividing it once again. We should probably keep in mind that each next level of subdivision will make it progressively harder for computers to calculate, but anyway, if we take a look at the statistics, we'll notice that currently our multi-res mesh is 2.6 million triangles, so technically it's even more than 1.7 million triangles of the original high poly mesh, so that is more than enough geometry to capture all the detail. What about the quality of the shrink-wrapped geometry though? We can definitely tell that even though the form has been captured pretty well, there are noticeable artifacts. I believe that some of these pinching issues can be tweaked by changing the wrap method to target normal project within the shrink wrap modifier. But still, it needs some more work. And I'm not entirely sure that target normal project was an improvement. You know, that happens in computer graphics all the time. We think that we improve stuff while we actually make it worse. That's classic. We can tell by these overly thin polygons that something is way off with the mesh, so let's probably roll it back indeed. The nearest surface point then is our choice. And poof, now the pinching is gone. I think our faithful shrink wrap modifier did its best, so we can apply it. So all the changes caused by the shrink wrap modifier get pushed into the multi-res. It's very useful because that's what we are going to be baking, namely the difference between the final amount of subdivision within Sculpt and Render, which is set to 4, and the viewport subdivisions that will eventually be set to 0. That will be our difference between the low and high resolution that will end up being rendered as the height map. So let me switch the viewport levels back to 4. And it's almost ready for baking, I think. But first we probably have to do something with pinching. It's no good to leave it like this. I think sculpting comes to the rescue once more. So Control Tab, Sculpt Mode. T opens the left tool shelf with all the brushes. Now we need some kind of a smoothing solution. In addition to the smooth brush that can be invoked by pressing Shift and the flatten brush, we have a very intriguing one called Mesh Filter. We can click on Inflate and change the mode to Relax instead. And now just click and drag and watch the whole thing get progressively more and more relaxed. Until it is completely chilled out and there is no visible pinching, I guess. Awesome. Simply awesome. I think we have prepared the multi-res data for baking. Now it's time to actually bake it. Finally, I'm going back over to the object mode and I'm preparing mentally for the baking process, which is going to be a little bit hardcore. Probably the biggest weakness of Blender compared to other baking tools is its inability to bake height maps from one model to another. Fortunately, we have this multi-res displacement baking workaround, where we bake detalization from the higher sculpt levels to the lower, but still it's not quite there. It's still not as intuitive as some other baking applications. That being said, by prioritizing Blender as our baking tool, we keep this workflow A, open source and free, and B, cross-platform. That's a major advantage, so let's roll with it. So what we're gonna do is bake 3 maps. The displacement map from multi-res modifier, the normal map from the high poly version of the model, and the diffuse map or the base color map from the high poly version as well. Let's start with the trickiest one, the height map. The basis of how the multi-res displacement baking works is that it takes the difference between the sculpt subdivisions and the viewport subdivisions, and it bakes this difference as a displacement map for the minimal subdivision level for the viewport. It is important, even crucial, to define what is our minimal level viewport subdivisions that we are baking for. In this case, we zeroed it out, so that's our minimal level. Okay, as Eevee currently doesn't support any kind of baking, we should switch over to cycles instead. It is very easy to miss this step and go, where are the baking settings? So, cycles. And as for the samples, we don't need that much. Actually, just 8 samples will be quite enough for the type of baking that we're aiming for. Now we have the bake from multi-res checkbox ticked, and the bake type set to displacement. That's practically all we need for our multi-res height map baking workaround, our secret sauce of baking displacement maps in Blender. Now in the upper left corner of the UI we have the shader editor. I have created a bunch of blank image texture nodes in advance. Basically you can add those image nodes from the Shift-A menu. I just did it in advance to save some time. So let us zoom into the first one, that will be our height map, and press New to create a new image file. We can be brave and set the resolution all the way to 4K, knowing that the baking process will actually be super fast. Let's call it displacement_bake. And it's also crucial to enable 32-bit flow checkbox, otherwise the displacement will have this weird stepping effect. After a new texture has been added, it can be found in the image editor. For now it's just black. I think we're ready by now to press the bake button with the displacement_bake image texture selected in the shader editor. That's important. Oops, no objects found to bake from. I think we simply forgot to do something. We forgot to select our object in the viewport, most likely. We can either click on it in the viewport or in the outliner. We should tell that it has become an active selection indeed by seeing an orange outline. That was easy to fix, right? Now let's click bake again, and it should go without a hitch. Luckily it's so fast to bake this type of texture, we should see it almost immediately in the image editor. Let's just pack it or save it externally, however you like. Otherwise we will lose it on quitting Blender, and that will be such a shame. Packing textures instead of saving textures has its own advantages and disadvantages. I did it to save some time, And anyway, the packed textures can be extracted into the folder with the blend file automatically. It'll even create a nice folder named textures for you conveniently. But if you're gonna save images by going Image, Save As, that's totally up to you, that's fine. Alright, what should we bake next? Now, the second texture will serve as a normal map, so let's click New, call it normal_bake. The resolution is set to 4K, let's disable 32-bit float now, and hit OK. Once again, it is important to select this particular image texture that you're going to be baking to, and with that done, the bake type can be changed to normals. So after selecting the normal_bake image and hitting the bake button, we should see the progress bar firing up at the bottom of the screen, and if everything goes right, get our normal map. Oh, the time flies, just a few seconds passed and we already have the normal map generated. Let's preview it out in the image editor to see if everything seems to be correctly generated. And personally, I have no objections, I think everything looks smooth. Now let's see what is still left to do. Well, first of all, before I forget, let's set up a proper displacement chain. Here I prepared an empty image texture coupled with the displacement node in advance. Let's disconnect it, move it to the left like this, and let's use the height map or displacement that we have baked from multi-res modifier. And it should go into the height input of the displacement node. Okay, and this empty texture node will become a holder for the base color texture. Clicking on New and calling it just like that. Base color _ bake. The base color texture doesn't have to be the 32-bit float image, so I'm leaving this checkbox empty. And confirm. Don't forget to pack the textures, or save them externally for that matter. This time we won't use the multi-res modifier as a source of baking data. We will use our high poly mesh with the diffuse texture instead. So let's toggle the visibility back on in the outliner. Select the high poly, then control-click on the low poly and make sure that that's the last object selected. And now we need to come over to the bake settings and change the bake type from normal to diffuse. Here it is. We are interested in the base color only, so both direct and indirect contributions should be turned off. Then it's absolutely crucial to get the selected to active checkbox ticked. That's why we have two objects and we are baking from one to another. As for the cage, we won't be adding a custom one. What we need to do though is adjust the extrusion. It creates a ballooned out version of a mesh to cast the rays from, so it's a safe bet to set it to a lower number like 0.01 or 0.02, something like that. Let's check the high poly model though first, because I have an impression that we have lost the diffuse texture somewhere. Let's check it out. I'm disabling the visibility of the low poly, switching to material preview so we can preview the diffuse texture, and indeed it looks blank. It looks like I managed to lose the diffuse texture along the way somehow. Let's inspect our high poly, and indeed, where is the texture? What's going on? That is awkward, but what I usually do in such cases is search in the image editor. And actually, here it is. It just has to be plugged back into the base color. So I click and drag it like this, and it goes into the base color. Hopefully that will bring things back to normal. So with this issue fixed, we can give it another try. I selected the high poly model first. Then let's enable the visibility of the low poly one, shift click on it. Then we can try to hide the high poly temporarily to see what we're doing. And it is super important to select the texture that is going to be used for baking in the shader editor. And with all the rituals fulfilled, we can at last return to the baking menu and hit the button again. Whoops, it prompts an error, no valid selected objects. I think we need to enable the visibility of the high poly mesh as well. That should do the trick. And then select both meshes, with low poly being the last one, and hit bake again. We can see the progress bar firing up, and that's the good news for us. Well, what's going on? Why the texture is black? We should probably disable multi-res modifier and try that one more time. You see, it's a bad omen to say the good news, because there is no good news in computer graphics until you actually see the rendered result with your own eyes. Baking again. So after a few miserable attempts of reprojecting the base color from high poly to low poly, we succeeded, and that's a good news, folks. Now we just have to save the image, or rather pack it. From now on, it will be a part of the blend file. And now it's time to build the material. So base color goes into the corresponding input of the principled BSDF shader. And as you can see, it looks pretty lifeless and flat. That's because we need to reconnect the rest of the inputs. Yes, our baked normal map, I'm talking about you specifically. In order to work properly, it needs the normal map node from the shader editor. It can be found in the vector tab. And before we use this normal map, it's important to switch the color space to non-color or to linear. Otherwise the bump mapping will look terribly off and totally crazy. So it goes into the color of the normal map, and then it is silently hooked up to the normal input of the material. Alright, that's looking much better already. To take it to the next level, we can make use of the displacement map that we have generated. As a quick refresher, the displacement map setup in Cycles looks like that. We have the baked height map, which goes into the height input of the displacement node in the shader editor, and in turn, this displacement node goes straight into the material displacement input. Then, to finalize the micro polygon displacement setup in Blender, we need to do a few things. First of all, we need to set up the subdivision modifier. Here we go. And enable the adaptive subdivision checkbox within this modifier. If you don't see the adaptive subdivision checkbox right away, it means that the Cycles feature set should be switched over to experimental first. And then the checkbox with the new option should appear in there, and it has to be ticked. But that's not all. Lastly, we need to visit the material settings. Scroll down all the way to the bottom of the settings until we see the displacement drop-down menu. There we need to choose displacement only. And hopefully after all these manipulations, we would be able to enter the rendered mode in Cycles and see the micropolygon displacement come into play. After some testing, we found out that after baking the modifier from multi-res data, the scale of the displacement node should be set to something like 0.05. That practically makes it look very close to the high poly version of the mesh, and so we think that's pretty close. Evidently, the scale of 1 is way too strong displacement for the height maps produced via baking from multi-res. So the scale of 0.05 seems to be the sweet spot. And in addition to that, the mid-level should be set to 0.5, but that's the default value for it, so we don't have to worry about it that much. It is worth comparing two meshes to make sure that we nailed the displacement settings indeed, because it can be pretty tricky to do right. So here is a quick comparison between the raw high poly scan at the bottom and the low poly version of it with the Cycles micropolygon displacement at the top. These two models look fairly similar to me. I think we can write it as a success. If you feel like watching a few more comparisons, here's how it looks in Cycles with micropolygon displacement turned on. Pretty awesome. And here is the same mesh but rendered in Eevee this time without any displacement. Just a good old normal map applied. And in my opinion that also looks pretty cool and detailed and realistic. It is still based on the photoscanned asset, and that's what gives it its charm. Obviously the realistic clothy stuff like that is notoriously hard to make in 3D, so starting with a photoscan is a blessing. It is amazing how far we went with the open source cross-platform photogrammetry pipeline, right? It is crazy to think that we can do all of this without buying any kind of software. And even though it's far from being the fastest workflow ever, but anyway, that's super impressive that we can set up the full photogrammetry pipeline by using only open source and only cross-platform tools. That makes this entire workflow super accessible pretty much to anyone. The only bottleneck I see currently is the hardware issue rather than software issue, which is an NVIDIA GPU is still required for most of the operations in both Mushroom and reality capture if you're gonna use reality capture for the same thing. Aside from that, that's super accessible, really. Thank you for watching. My name is Gleb Alexandrov. You're watching Photogrammetry course, in which we explore various ways to create amazing photorealistic 3D from photos.